Hello everyone, and in this video, we're going to be discussing an important lemma from geometry, which states that the incircle chord connecting the two tangency points, the angle bisector, and the line connecting the two midpoints all concur at the same point, P. And I'm also going to provide some basic motivation on how we would get this proof in the first place. So, a general way of proving that three lines are concurrent is suppose that BI and EF intersect at a point P prime. They want to show that P prime lies on MN. Well, suppose that were true. Then if this angle here were equal to beta, then this angle here would also equal beta because it's the angle bisector. However, we know from geometry and the medial triangle configuration that MN is parallel to AB. So this is 180 minus 2 beta. And by simple angle chasing, we get that angle P prime N is equal to beta. However, this means that triangle BNP prime is isosceles with BN equals NP prime. But however, BN is equal to CN, so BN is equal to NP prime is equal to NC. This means that N would be the circumcenter of this larger triangle here. However, since this lies on this side and it's a midpoint, then we can deduce that line BP is a right angle. So we can say that this line angle here is right if we have that P prime lies on MN. So what we'd like to show is that if P were equal to P prime, then we'd like to show, let me go ahead and get rid of all of this stuff here. We'd like to show that BP is perpendicular to PC, as this would imply that it's a right angle, and we'd be done. So how can we get started on this one? So we know that angle BPC is equal to angle IPC as well. And if we were to prove that this is 90 degrees, then we can also note that here, since we have tangent, might as well just draw the radius. And we also note that angle IAC is equal to 90 degrees. So the problem ended up reducing to proving that IEPC is cyclic. So which angles would seem the most suitable to do it? Let me go ahead and draw this line here. Well, we already know what angle ECI is. And if this is gamma here, gamma, and then this is beta and beta, and then we draw this line here just so that we can complete the angle bisectors and get alpha and alpha. And this is just equal to gamma. Then all we have to do is prove that angle EPI is equal to gamma. So suppose that angle EPI was equal to gamma, then that would mean that angle FPB is equal to gamma as well. However, we already know an angle inside this triangle here. So if we can find out this other angle here, we'd be set. So, however, this is alpha, and we know that AI is perpendicular to EF, since AE is equal to AF, meaning that it's isosceles, and this is the angle bisector. So this means that this here is 90 minus alpha. So this means that it would be 90 plus alpha here. And now we can just finish it up. So we then have that 90 plus alpha plus beta plus angle FPB is equal to 180 degrees. So angle FPB is equal to 90 degrees minus alpha minus beta. And we'd like to show in the end that this is equal to gamma. So might as well move the alpha and beta to both sides, get all the variables on one side. We get alpha plus beta plus gamma is equal to 90 degrees. And that's what we want to show. Since we have a lot of angle bisectors here and we want to get the sides of a triangle, we want to multiply by 2. So 2 alpha plus 2 beta plus 2 gamma is equal to 180 degrees. You might see where this is going already. 2 alpha is an angle here, 2 beta is an angle here, and 2 gamma is an angle here at angle C. So that means that all the angles add up to 180 degrees. And we're done. So let me go ahead and give the highlights of the proof real quick. So it turns out that angle BPC is equal to 90 degrees because angle EPI is equal to gamma, which is equal to angle ECI, which implies that EPCI is cyclic, and then that implies that angle BPC is equal to angle IEC, which is 90 degrees. And then we conclude by noting that N is a circumcenter of triangle BPC. N is circumcenter of triangle BPC. And that means that this is here is beta. This here is also beta. This is 180 minus 2 beta. However, that means that PN is parallel to AB. And we know that PN must pass through M as well. Therefore, all of these lines are concurrent, as we needed.